Artificial intelligence and machine learning are two related but distinct fields of technology that are currently revolutionizing many industries. AI refers to the simulation of human intelligence in machines that are programmed to think and learn like humans. This includes the ability to reason, problem solve, and understand natural language. AI can be used to develop intelligent systems that can analyze data, make predictions, and even make decisions autonomously. On the other hand, machine learning is a subset of AI that specifically deals with the use of algorithms and statistical models to enable machines to learn from data and improve their performance on a specific task without being explicitly programmed. It is a method of teaching computers to learn from examples rather than being explicitly programmed. This is done by training a model on a dataset, which is then used to make predictions or decisions on new, unseen data. Both AI and ML are rapidly advancing fields, and they are being applied in many industries, including healthcare, finance, transportation, manufacturing, and more. They are being used to develop intelligent systems that can analyze data, make predictions, and even make decisions autonomously. There are several different types of AI, each with their own unique characteristics and capabilities. Reactive machines are the most basic type of AI. They are able to react to the environment but do not have the ability to form memories or make predictions about future events. These machines only respond to current inputs and cannot use past experiences to inform their behavior. Examples of reactive machines include chess-playing computers that only respond to the current configuration of the board. Limited memory AI is a step above reactive machines, as they have the ability to form and retain memories. These machines can use past experiences to inform their current behavior, but they cannot make predictions about future events. An example of limited memory AI is self-driving cars that use cameras and sensors to detect and remember the position of other vehicles and pedestrians, but cannot predict their future movements. Theory of mind AI is more advanced than limited memory AI, as it is able to understand and simulate the mental states of other agents. These machines can understand that other agents have beliefs, desires, and intentions and can take them into account when making decisions. An example of theory of mind AI is a virtual assistant that can understand the user's goals and preferences. Self-aware AI is the most advanced type of AI. These machines have a sense of self and can reflect on their own mental states. They can understand their own beliefs, desires, and intentions and can use this understanding to make decisions. However, this type of AI is still purely theoretical and it is currently not possible to build a self-aware AI. It's important to note that these types of AI are not mutually exclusive and an AI system can have elements of multiple types. Also, these classifications are not strictly defined and may vary depending on the source. Machine learning, ML, is a method of teaching computers to learn from examples rather than being explicitly programmed. This is done by training a model on a dataset, which is then used to make predictions or decisions on new, unseen data. There are three main types of ML: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is the most common type of ML. In supervised learning, the model is trained on labeled data, where the correct output, also called the label, is provided for each input. The model learns to make predictions based on the patterns it observes in the labeled data. Examples of supervised learning include image classification, where the model is trained on labeled images of different objects and then used to classify new, unseen images, and speech recognition, where the model is trained on audio recordings of speech and their corresponding transcriptions, and then used to transcribe new, unseen audio recordings. Unsupervised learning is used when the data is unlabeled, and the model must find patterns and structure in the data on its own. There are different types of unsupervised learning, but the most common one is clustering. Clustering is the task of grouping similar instances together without knowing the class labels. An example of unsupervised learning is anomaly detection, where the model is trained on normal data and then used to identify unusual patterns or outliers in new, unseen data. Reinforcement learning is a type of ML where an agent learns to make decisions by interacting with it and receiving feedback in the form of rewards or penalties. The agent's goal is to maximize its cumulative reward over time. An example of reinforcement learning is a robot learning to navigate through an environment by moving around and receiving rewards for reaching its destination and penalties for crashing into obstacles. AI and ML are being applied in various industries to improve efficiency, accuracy, and decision-making. In the healthcare industry, AI and ML are being used to analyze medical images, such as X-rays and CT scans, to assist doctors in diagnosing diseases. They are also being used to analyze patient data, such as electronic health records, to identify patterns and predict potential health issues. Additionally, AI-powered chatbots and virtual assistants are being used to assist with patient triage and provide information on symptoms and treatments. In the finance industry, AI and ML are being used to detect fraud transactions, identify potential market trends, and make predictions about stock prices. They are also being used to analyze large amounts of financial data to identify patterns and make more informed investment decisions. Furthermore, AI-powered chatbots and virtual assistants are being used to assist customers with account management and financial planning. In the transportation industry, AI and ML are being used to improve self-driving car navigation and make the traffic more efficient. They are also being used to optimize logistics and delivery routes and to monitor and predict vehicle maintenance needs. In the manufacturing industry, AI and ML are being used to improve quality control by analyzing sensor data to detect defects and predict equipment failures. They are also being used to optimize production schedules and to improve supply chain management. While AI and ML have the potential to bring many benefits, there are also a number of challenges and limitations that need to be addressed. One of the biggest challenges is the issue of bias. Because AI and ML systems are trained on data, any biases present in the data will be reflected in the model's predictions and decisions. This can lead to unfair and discriminatory outcomes. There are many ways bias can be introduced in AI models, including biased data, biased algorithms, and biased decision-making. Another challenge is the lack of interpretability and explainability of AI and ML models. Because these models are often complex and opaque, it can be difficult to understand how they make decisions and predictions. This can make it difficult to trust the model's output and to make sense of any errors that may occur. Another challenge is the issue of safety, particularly when AI and ML systems are used to control physical systems such as self-driving cars, drones, or robots. Ensuring the safe operation of these systems is crucial and requires robust testing, validation, and verification. Tell us about how informative is the video by giving rating to us out of 5 in the comment box, because making this type of video take too much hard work. Also like the video to motivate us.